Hello everyone, welcome back. This is part 3 of the Solid Design Principles tutorial. In this session, we will discuss interface segregation principle and we'll take a look at the case study of interface segregation principle and we'll implement interface segregation principle with a simple example. Please refer to the previous parts of the tutorial before proceeding. In the first session of Solid Introduction, we have understood that I in the solid is acronym for interface segregation principle. The interface segregation principle states that no client should be forced to depend on methods it doesn't use, which means instead of one big fat interface, many small interfaces are preferred based on groups of methods with each one serving one submodule. The interface segregation principle was first used and formulated by Robert C. Martin while consulting for Xerox. Let us now understand how the interface segregation principle was evolved with a case study. As we all know that Xerox Corporation manufactures printer systems. In their development process of new systems, Xerox has created a new printer system that could perform a variety of tasks such as stapling and faxing along with the regular printing task. The software for this system was created from the ground up. And as the software grew for Xerox, making modifications became more difficult so that even the smallest change would take a redeployment cycle of an hour, which made development nearly impossible. The design problem was that a single job class was used by almost all of the tasks. Whenever a print job or a stapling job need to be performed, a call was made to the big job class. This resulted in a fat class with multitudes of methods specific to variety of different clients. Because of this design, a staple job would know about all the methods of the print job, even though there was no use for it to know about these different interface methods of a print job. To overcome this problem, Robert C. Martin suggested a solution to Xerox, which is called interface segregation principle. Instead of having one large job class, a staple job interface or a print job interface was created that would be used by the staple or print classes respectively. This solution has evolved into an interface segregation principle which states that one large job class is segregated to multiple interfaces depending on the requirement. Now, if you recollect the previous session, we have also covered the interface segregation principle along with the single responsibility of the class. We strongly recommend you to refer to the single responsibility session before proceeding. In the previous session, we have decoupled the user class to achieve single responsibility of handling login and registration. Also, we have moved the error logging and send email methods to their respective classes or interfaces. After those changes, we have achieved single responsibility from the respective classes perspective. But if you take a closer look at the same example from the perspective of interface segregation, we have as well separated or segregated one big interface which handles login, registration, email, and error logging to multiple interfaces, adapting to interface segregation principle. Now let's understand the interface segregation principle in greater details with one more example. In the beginning of this session, we have discussed that Mr. Martin has solved the issue at Xerox by segregating the interfaces based on the usage and not by enforcing the clients to implement the interface methods. Let's take the same case study example and see how we can achieve the interface segregation principle. Let's now open the Visual Studio and bring up a console application. Let's now create an interface that performs printer related tasks. Right click on this project, add new item, choose an interface, and let's name this interface as I print tasks. Let's make this interface as public. Let's add the task that a printer can perform. Let's add a method bool print content, which accepts string content as input parameter. Let's create some more methods. Let's just, to save some time, let's copy this method and change it to scan content. Let's also create another method, fax content, and the last one, which is photocopy the content. These are some of the typical methods or the tasks that a printer can perform. Now let's say in my office, I have a HP printer that need to implement these methods. To save some time, I have already created the HP printer client class that implements the created interface. If you take a look at this class, I have implemented the iPrint task and doing a simple console.writeLine and returning true. I have done the same implementation for all these methods to make this example very simple. Now, it's all fine till this moment. The actual problem starts when I have a Canon MG2470 printer that can only perform print, scan, and photocopy operations, as it doesn't have the ability to fax the content. In that scenario, we are stuck implementing all the interface methods, and we need to explicitly and gracefully handle the method that cannot be implemented. Let's right click on this client folder, add a new item, choose class, and name this class as Canon MG2470. And let's implement the iPrint task. Let's implement the interface. Now please notice that even though my Canon home printer cannot perform the fax operation, still it is enforced to implement all the methods of the iPrint task interface. This is one of the major problems that we encounter in the day-to-day programming. And this is only one part of the problem which we have discussed here. Now let's say there are some advancements in the printing technology where it can print the duplex content as well. Let's say this iPrint task can print the duplex content as well. Let's represent it as print duplex content, and let's pass the content as the string parameter again. With this new methods addition, all the clients are mandatory forced to implement the newly added method as well. This is the second part of the problem. Both of these problems can be addressed by segregating one big fat interface to smaller relevant interfaces. And that solution is called interface segregation principle. Let's see how we can do that. To save some time, I have already segregated the related methods to smaller interfaces that are relevant to different clients. For example, a minimum basic printer can perform print, scan, and copy operations, and advanced printers can perform fax or duplex content printing based on the level of the printer. Hence, those methods are separated into different interfaces. I believe now you have a good idea on how we can implement interface segregation principle. In the next session, we will focus on O acronym in SOLID, which is open closed principle. Till then, thank you for listening and have a great day.